Welcome again, Wildcats. Alright, so today we're looking at Monday, September 25th, solving absolute value functions using graphs. Okay, and that's on page 13. So if you would, pause the video and update your table of contents. Now, while you're updating your table of contents, let me promote here my new promotion here. Understand that some of you in the math world like to write in pen. Okay, so I know that's a craziness because I think you should use a pencil, but if you have to use a pen, you should use a friction pen. Okay, because they erase. These are pens that erase. So if you're a mom out there, a dad out there, a student out there that likes to write in pen, go out and buy. I got these from HEB. They're a little pricey, but they're awesome. Friction pen. Okay, so and that's what I'm gonna use today. Okay, is the friction pens. All right, so with that, let's go ahead and look at our notes, okay? All right, so they're on page 13, solving absolute value functions, okay? Let's start by reviewing the definition. The definition of absolute value is x such that x is greater than or equal to 0 and negative x such that x is less than or equal to 0, okay? Now let's look at our steps, okay? Solving steps. Step 1, isolate the absolute value. Step 2, graph the left side. Step 3, graph the right side. Step 4, find the x values of the intersection from the graph. Okay, so go ahead and update the solving steps. All right, so now let's look at the types of absolute value function solutions. So you have no solution when absolute value of x equals a negative number. When that happens, the left side and right side will not intersect, so no solution. Okay, you have one solution, okay, when absolute value of x equals a number, or actually, I'm sorry, when absolute value of x equals 0. And then you have two solutions if absolute value of x equals a number, okay? So no solution equal to negative number, one solution equal to 0, and two solutions when absolute value of x equals a number, okay? Let's just say a positive number, okay? All right, so with that, update your notes. All right, now in the video, I'm actually just going to do example 2, 4, and 6. So because it's on the right side, I'm actually going to fold my paper so it's easier to see just this side. Okay. All right. So using friction pen. Whoa, friction pen. All right. I'm a little nervous. I've never used a pen using math, so this is going to be exciting. All right. So step 1, isolate the absolute value. Okay. All right. So the absolute value is isolated. So now we move on to step 2, graph the left side. Okay. So to graph the left side, we first move the vertex. Okay. So we know the vertex is a 0, 0 for the parent function. So the transformation, since it's plus 1 on the inside, we move left 1. Okay. And then from there, we want to graph by direction. Well, we know the direction of absolute value, HK, well, that's the vertex that we moved, okay, is 1, 1, 2, 2, 3, 3. Okay. So from here, we go to the right 1, up 1, to the right 2, up 2. Now, if I hypothetically made a mistake, which I didn't, using a friction pen, watch this, actually erases. Whoa, isn't that crazy cool? But in fact, that point is correct. To the right 2, up 2, okay, and then to the right 3, up 3. Now, the vertex here is where the symmetry occurs, okay? We know that absolute value is symmetric, okay, about this, in this case, x equals -1, okay? So we can graph using symmetric points. So this point was 1, 1. Symmetric would be left 1, up 1, left 2, up 2, and left 3, up 3, okay? All right, I didn't bring my ruler. As you can see, I'm kind of been moved. There's another teacher using my room, so I'm in the cafeteria, so I don't have my ruler. But when you don't have a ruler, you improvise. I'm gonna use this. I think, I don't know. It's some sort of phone, And so I'm going to use the phone as a ruler. Seems to work as a good ruler. All right, now we're into step 3, graph the right side. Well, that's y equals 3, so it's a horizontal line at 3. So 1, 2, 3. All right, and so then find the x values of the intersection. So the intersection here is that x is negative 1, 2, negative 1, negative 2, negative 3, negative 4. So x equals negative 4. Okay, or x is 1, 2, because that's from the intersection. So x equals negative 4 and x equals 2. You're only looking for the x value of the intersection. Okay. All right. So at this point, what you might do is if you're using a flexi pen, you can do that, or pencil. Try example 4. Okay. And then once you tried it, then unpause the video and then follow along with me to see if you're correct. If you made any mistakes or any, you can erase and adjust. Okay. And again, remember, parents or students watching there, I'm going to go over these examples again in class if needed. Okay. All right. So example 4. All right. Step 1 says isolate the absolute value. So to isolate the absolute value, okay, we're going to subtract 3 from both sides. Okay. So that cancels, you get the absolute value of x equals 0. Okay. So step 2, graph to the left side. So the graph to the left side, this is the parent function's absolute value. So we know that 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And then again, the symmetric points negative 1, left 1 up 1, left 2 up 2, left 2 right 2, left 4 up 4, left 5 up 4. Okay. All right. So next is step 3, graph the right side, which is 0. Okay. So the intersection point is at x equals 0. All right. Let's look at the next one. Now, the negative, and the reason why I'm doing this is because that makes it a little bit more difficult of the problem. But I think, again, knowing your notes, you might try example 6, and again, unpause it and follow along with me. Okay. But if you're a little nervous, you can just follow along with me now as well. But for those of you, I just want to give the opportunity for those of you who want to try it first. Okay. All right. So let's look at step 1. Isolate the absolute value. Okay. So to isolate the absolute value, we're going to divide both sides by negative 1. So you get the absolute value of x plus 1 equals negative 3. Okay. And then step 2, graph the left side. So again, we're going to graph by transformation. So we move the vertex left 1 unit, and then we're going to graph by direction. Now HK, that was our vertex. Okay. And then we know 1, 1, 2, 2, 3, 3. Okay. So that tells us to go to the right 1 up 1, to the right 2 up 2, to the right 3 up 3. And again, we can graph by symmetry, and we know it's symmetric. So we go left 1 up 1, left 2 up 2, left 3 up 3, and then we have our graph. All right, and then we graph the left side. Or I'm sorry, the graph step 3 is graph the right side. So we graph y equals negative 3. So we go down 1, 2, 3. We can see that they do not intersect, so there's no solution. All right, and so I'm hoping you see that I did examples 2, 4, and 6 on purpose because example 2 shows an example of 2 solutions. Example 4 shows an example of 1 solution. And example 6 shows an example of no solution. Okay. Now remember, if you had trouble with any of those, I'll go back over them as needed in class. I'm hoping you saw that and that goes for any parents or students watching, I've made some adjustments. I've shown the step here, and I've shown the step here, okay? So I'm hopeful that helps clarify some understanding as we're working through the problems, okay? So with that, I'm in the cafeteria, so I think I should get some of our awesome Wildcat food. So I think that's what I'm going to do. So with that, have a wonderful Wildcat day.